Hello, I'm Lamar Copeland, and today I will be presenting on cloud computing challenges for e-healthcare. E-health is an immensely popular and important field today for obvious reasons. Keeping databases for medical records, patient identification, and prescriptions has been made much easier with the integration and increased technology for medical institutions over the years. Figure 1 is the ecosystem of e-health domains. Possible benefits of cloud computing for e-health. The benefits of cloud computing are amazing for businesses. Administrative maintenance and infrastructure costs can be cut down, and investments for infrastructure can be avoided on the front end. In other words, all the time and work that businesses put into developing, maintaining, and securing their in-house network connections and administrative infrastructure can be dedicated to the cloud. Risks of cloud computing for e-health are threefold. Number one, cloud computing data centers can have outages. Number two, a single cloud service distribution center can't service users across the globe with good latency. And number three, due to restrictions and laws that regulate cloud computing security, it could become difficult for medical institutions to pinpoint the proper universal settings to upload onto every location under their medical institution's name. The fog cloud computing approach to latency issues. The latency issues posed by cloud computing have been addressed by a joint fog cloud computing system. It basically means that when cloud computing is being used, there will be a way to establish a supplemental connection that has its source stemming from the edge of the cloud to the medical institution. This supplemental fog connection decreases the threat of high latency by a large degree. In Figure 2 and 3, you can see the difference in execution time of cloud computing tasks compared to fog computing tasks. In Figure 4, we have an existing cloud computing model. In this service-oriented architecture, the user interface clears up space for the cloud to store information using web services for the client. However, this model leaves room for security breaches in the system on the client side. A security-based improvement for the cloud. Another proposed cloud computing model in Figure 5, the cloud server receives data from the patient in a one-way flow that doesn't allow him or her to access information from the cloud. However, the data owner or the medical institution can receive and provide data. Another model from a different study revealed similar security issues in cloud computing systems. While this system is robust, the way to access information in the cloud is through encryption keys. With this method, the system is efficient. However, if it is breached, the system cannot determine the insider's identity. With the modified insider threat detection model, instead of encryption keys, there are bioinformatic data that can be used at the modules to access the cloud. This way, it has become easier to pinpoint who exactly is causing the threats. Conclusion recommendation. E-health is an essential system in our society. E-healthcare stands to advance greatly by incorporating cloud computing. The barriers to this upgrade are risks in security, performance, and efficiency. While there have been several successful studies done to mitigate these risks, it would be best for current medical institutions to wait a few years before moving their databases to the cloud to allow methods of e-health implementation to be made more secure. This way, medical databases can remain consistent and protected even after transition to the cloud. In addition, as time goes on, issues with latency and service stability will likely be mitigated with tested and reliable solutions. While the benefits of cloud computing are astounding, the current risks associated with using it are too great to implement for an e-health system currently.